Hello again. This is RXBDEMO5. This is the document for, the documents I should say, for RXB 2012. This is the table of contents right here. There are a few changes. I've gone through all of the RXB for documents, for programming, for the GPL, and look for any errors I can find and change them. So I just wanted to rotate through you and show you things. Like, let's do this is the title screen here of RXB. This shows you what happens. You can press any key for disk number load. You can press enter and get disk one utility load, or you can press comma and get a batch. Now, in the last video, or previous video, I already showed you batch. That was in the 3 videos I originally started with the RXB demos. Spacebar goes to XB. This goes to Enter Assembler. And an added feature for 2012 is this. Enter defaults to WSD1 load or WSD1 utility. So here's how it works. We hit 0. WDS1 load. Or we can hit enter and hit 0. And it tries WDS1 load utility 1. Okay, that's that. Let's jump on down here. This is a listing of some of the features in RXB, including what I just explained to you right here. This is a listing of features in RXB. I wanted to simply note this. This is the hard drive and disk drive access. Now in Classic 99, mostly it's useless, but it works in a regular TI. So if you have a gramulator, graham cracker, pgram, high-speed GPL card, or manufacturer module, this will work fine for you. One of the commands I wanted to look at here just to show you was on Sector. Sector will handle hard drives, including the SCSI hard drive, up to 2 terabytes. I don't think anybody else has done a Sector routine in Extended Basic except for me. Here's Cut Directory. This is a feature that was built onto the SCSI card only. Horizon came out with a SCSI card with an updated EEPROM, and Cut Directory only works on it. So in the future, if somebody can copy this and put it on different hard drives or versions of hard drives, this would be great because it deletes directories, subdirectories, and sub-subdirectories, and all the files inside. So it's dangerous, but it's useful. We have also remove directory, which just removes directories, but the directory has to be empty if you remove it. And it can't have any subdirectories in it when you use it. So I just wanted to show you those. Well, also I have copy files. It'll copy it'll copy up to, I think, like 32. I think you can copy 32 files at the same time with one command to 32 different drives if you had them. That's what it's capable of doing. Anyways, then we have user. I already showed you input output, which is the ability to control the CRU chip on the TI from Extended Basic, like plain sounds. And then we have the redo key is missing from RXB. It's been removed for the ability to use user. As I stated before, it was useless because it's 152 bytes for the data buffer when you're typing in stuff on the data buffer, like this. That's only 152 bytes long, but the token buffer is 163 bytes long. So when it's tokenized, it's 163, but the buffer you're using to put it in is only 152, which is why you had to push the redo key so many times. It was kind of amazing that it ever got past Texas Instruments to be put out on the market like that. They made a major mistake. Program name, device name, and this is something I was showing you before, like we can go call basic. But of course it won't work from this mode. So you can use a thing called an EA, you can use a DSR, device service routine. It's built into GPL, but everybody should be using DSRs that use it. So we can go EA. If we're in EA, we can go basic, or we can go old, and we can go XB. Whoops. Oh, I switched too many times. Stack got filled up. You don't normally do that. When you do DSR switch over and over again, it goes onto the stack, and the operating system doesn't pop it off the stack, and so what happens is you get a crash after you do it several times. It'll pop it off the stack anyway the first time that you do a garbage collection in Extended Basic. But TI Basic doesn't have a garbage collection that's used very often, and neither does the editor assembler. So that's why it crashed. Okay. Anyways, back here, device access I did already. Assembly language programmers, I have execute. I'll show you that later on the demos. Direct access is what that's called. AMS support. This is what I'll be doing shortly in the next few minutes. And then we have interrupt service control, which is an interrupt service routine is like a mouse or screen dumps when you use that interrupt service routine to use like a switch to switch it on and off to hit a button. That's the interrupt service. Well, there's other things that have interrupt service too. I have a built-in one that saves that interrupt address or restores it into RXB. It's built in. And then you have a hidden loaders, then we have a thing called bload and bsave. So what we're going to do now is we're down at the first one, AMS bank. So here we go. Okay, this is the command AMS bank, and what it does is it sets up your AMS so you can use it for bank switching. But before we do bank switching, there's another command here that's farther down. Let's jump down to it. It's called bload and bsave. Those are the AMS commands. Okay, bsave, what it does is it takes the lower 8K and creates a EA5, or not EA5, excuse me. It creates a program image file on the disk of the lower 8K, and then bload will load that file. What is that useful for? Well, I'm going to show you. What we're going to do here, oops, let's go back to 6. What we're going to do is here, this is what's on disk 6 right now. So here's what we're going to do. We're going to go load this file called AMS test. And we're going to run the file. AMS test was written originally in assembly language with call links by Paul Shipnick. And what it did is it examined the AMS card and it looked for the memory that you had in the AMS, and then it would show you what memory is being used and where, and how many pages are available. If you look at this, I'll include it in the package with RXB. It shows you all the commands that I took from assembly language and turned links and turned them into GPL commands you can use. Yes, they are slightly slower, but they're more accessible, and you don't have to load anything to make them work. It's kind of crazy to have to use a call link to talk to the AMS so you could switch pages in the AMS. More than a big problem. There just wasn't any way to pull it off. RXB on the other hand has the ability to do that because you're using GPL. So you don't need to use the lower 8K to access the lower 8K, which was the problem that AMS always has had from Extended Basic. Let's move on. I have a program here called load, it's called bloader. Let me show you that program. It starts up a loop from 1 to 20. Then bload loads off of disk these programs right here, which are the image files, screen 1, and then it's got screen, and then it adds in a string of A, which is going to be 1 to 20. Then what it does is it uses a command called in RXB called moves. It moves from RAM to video, 2079 bytes from the lower 8K, because this moves it into lower 8K. It moves it from 2000, which is 8192, which is the same thing as the lower 8K's first byte. And it moves it onto screen 0, which is the address up here. Then what it does is it does a delay loop, and it does a next day, and then it just restarts the program again. Let's run it and show you what it does. All these are is just copies of different games, and then I froze the game and added the bsave command to save the graphics. Now you can see that you could, if you run a game to set up graphics and then use this to load the graphics, it would be much quicker and much faster. And you could do as many of these screens as you want to because it loads all the VDP memory for you for where the graphics are. It doesn't affect your string memory because the string memory is in a different spot. So it doesn't affect the stack or the string. It only affects the graphics, which is what you'd want to load, which is what I'm doing right now. Whoops, that's 5'2". Anyways, so it's done this. So this is with a delay loop of 200. So let's break out of this and see how fast it is without it. We take out 130, which is the delay loop, then run it. From Classic, it loads pretty fast. And it does pretty well. If you're going full speed, of course, it's just insane. It rotates back around again. Okay, let's break out of this. Let's go to the next step. This program here is slightly modified. What we have here is I initialize the AMS card that's in the TI, or the Classic 99. I do the same loop from 1 to 20. I do an AMS bank of A, which is going to be bank 1. It's going to be 1 in there. Then I'm going to, instead of adding the next bank with like +1, the reason why is because as I rotate through, it's going to be 2, so I'd write over the top of my bank. So it's easier if I just do this, bank 1, or the lower half of 8K. There's two halves. Lower 8K is broken up into two spots. It's going to be one half here, which is the lower 8K, then the other half is over here, which is the upper half of the lower 8K. Because AMS works in 4K pages, not 8K. So you have to have two 4K pages, not one 8K page. So lower, upper. So that's what we're doing here. Lower and then +20, the upper. Okay, we're going to beload the same thing. We're going to move the same thing we did before. We still have the delay loop here. And then we have a 4 next here to just go back into the MS and then just move them on the screen with a delay loop. So let's run this program. It's going to look the same as it did before. It's going to load all the screens. The only difference is right now that is it's saving them into the, when it loads them into an AMS bank for use later. And then after this loop completes to the last picture, we're going to move into the step of showing you AMS bank as it switches in the pictures from memory instead of loading them off disk. Presently, it's loading them all off disk. Next, we're going to load them out of memory only. So when it gets to the last one, it'll start doing them from memory. Okay, this is from memory. A little faster than disk. But I still have a delay loop in there. So you can see that it loads fairly fast. Let's do something here. Let's take out the delay loops. 150 is a delay loop. Let's take that out. The other delay loop is right here at 200. Okay, this is running without delay loops. Whoops. This is loading the AMS pages right now. We don't need to do it again, but you know, I ran the program from run. I should just ran the second half of it to show you the difference. But when it gets to the AMS loop, it'll continue to loop in the AMS from memory only to put the pages. So my ideas with Extended Basic is to load the screens, put them into the AMS, and then from Extended Basic, reload them again. Your programs could be much quicker, much easier to use, and better graphics. Whoops, forgot to put a loop in there. Yeah, okay, 220 should be go to 170. Let's run 170. This is just memory from the AMS. It's pretty effective storage medium. It goes so fast that it doesn't even get a chance for the video processor to catch up to put it on screen correctly. because it's outrunning the video processor. That's the reason why you see some images over the top of the other image. It's just that fast. It's GPL though, it's not assembly. So GPL is fast enough to actually outrun the VDP chip. Slightly. But this is on Classic. I don't know if this would happen with the TI. Anyways, you see the point. I just wanted to show you that, what's capable.